Hello everyone, my name is Rob Krug, and I'm a Senior Solutions Architect for SonicWall. Today I'd like to talk about HTTP Evasion and what it means to the security architecture that you may be deploying in your enterprise. HTTP Evasion has been around for about 20 years now. It's the art of actually using a combination of tactics to bypass or circumvent your traditional intrusion prevention or intrusion detection systems. Now, the way this system actually works is that the attacker will use customized code and scripting to slice and dice packets to appear much smaller than they typically would be in order to smuggle them through your firewall or your security detection systems. Basically, it's a way to obfuscate and hide the code embedded in normal looking packets so that the firewall and or IDS systems cannot detect it and thus slip through your security inspection. This is kind of how it works. In a traditional network, you may have your end user computers, your firewall or your IPS IDS systems connected to the internet and then that far end destination web server. An attacker who has compromised that web server will wait for your user to start sending traffic to the website. In the presentation or the delivery of that web content, what will happen is the attacker will typically embed different code. Let's take a look at some of the code, how it actually takes effect. In a traditional attack, when a user downloads a malware package, where the file may be an executable or an actual zip file, something along those lines, and the file gets downloaded from the website and comes across the firewall is able to actually see this malware or intrusion exploit and kill that particular packet. With HTTP evasion, rather than using the entire payload of the packet that contains that executable, what the attackers will typically do is slice and dice it. So it works a little bit like this. When that packet's coming through, and you can see here on this rapid fire little snapshot, all these packets are coming through while those files and packets are going back and forth between the client and the web server. What the attacker is doing is injecting minute amounts of the code in each one of these packets. It looks a little like this. This packet, this blue arrow here, represents the packet. And in that way, the attacker will do it is embed a small string of code that is a small piece of a malicious exploit kit or a malware package. Once this piece actually gets through the firewall, because it's considered benign, it's not big enough to be detected as anything malicious. It may be only a small portion of the code of the exploit package. So what's actually happening is it's being smuggled through your firewall. Now, the way the code is designed, the way the attackers embed the code in this HTTP evasion tactic is that once they are able to successfully smuggle it through the firewall, well, then that code will recompile itself on the inside of your network. Just as you see here, the malware is being delivered, reconstructing itself on our internal network, and before you know it, you have a reassembled, weaponized exploit kit or malware attack, and your network has been breached. In this particular attack, hackers can deliver any kind of content they want. They use it by manipulating this TCP and IP handshakes of the website, UDP handshakes of the site in order to deliver the content to the end user terminal. So by using that manipulated code, they're able to deliver their payload. In this case, in the way that the SonicWall will actually protect your network, is we actually leverage what's referred to as the deep packet inspection model. So in this particular case, you'll see the little blue arrow at the top here, where the red dot is coming into the firewall. Well, as that packet hits the SonicWall appliance, and it's containing malicious code, now, and using the HTTP evasion scripting in order to circumvent the firewall, the SonicWall appliance, by leveraging our deep packet inspection, is able to actually analyze this packet even though it's been sliced and diced. We're able to see that that packet contains something malicious. We're able to see that it's not conforming to the standards of normal web traffic. And what we're able to do is actually block and discard that packet from entering the network. In this particular case, the SonicWall will block that HTTP evasion packet from even traversing the firewall, while continuing to allow the good content. So packets that are formed correctly and not using HTTP evasion are still allowed to pass, provided, of course, they don't contain any malware. So this is how the SonicWall will actually prevent this type of attack. Now, you may remember last summer when one of our competitors hosted a YouTube video showing that their own ability to block HTTP evasion techniques that contain certain test malware. By leveraging an online testing site shown here and leveraging the iCar test virus to demonstrate their security efficacy, they ran through a couple of series of tests The first one that they're actually going to run here is, this is again from their own YouTube video, is showing their firewall basically out of the box configuration. No special configurations, no best practices, just straight out of the box. Out of 735 attempts, the firewall was successful in only allowing 110 evasion attempts to get through. So they were able to block all but 110. That's pretty decent out of the box, I suppose. But when they actually turn around and run the test again with what they considered their best practices and latest greatest firmware, they were successfully only able to block all but 79 evasion attempts. So 79 threats still got through. Well, SonicWall, in answering this challenge, decided to duplicate the same exact test. By leveraging the SonicWall appliance and a Windows test machine, similar to the video you just saw from our competitor, and the exact same online testing site, again hosted at this location, we ran the same iCar test virus. Now, it's the test through the firewall, using all the same HTTP evasion scripts that the competitor used. Now, this first configuration is out of the box, and it does take quite a while to run. So we'll skip ahead briefly here, and a little while later, we actually can see the results. Out of the box, the SonicWall was successfully able to block all but 79 attempts. That's very reasonable, considering that was the competitor's best practice numbers. If we apply the SonicWall best practices to the appliance, you can see these test results that only 6 evasion attempts were not blocked. So only 6 threats got through. But SonicWall blocking 6 attempts, blocking all but 6, is still not good enough for us. By leveraging the SonicWall grid network, our data centers wrapped around the world, and collecting the intelligent feeds that we use to create and identify new threats, and then taking this information and analyzing it across a global distribution network that allows our threats team to identify threats from over 1 million different sensors, we can actually identify additional HTTP evasion scripts, additional attacks, different malware. By analyzing all of these threats, the SonicWall IPS team is able to go and create new signatures to match threats and of latest generation of malware, attacks, and exploit kits. By identifying these new threats, we can then add them to the grid network, where these new signatures are automatically downloaded to the customer firewalls. You can see here where our IPS team is actually pushing those new signatures directly out to our managed firewalls, all through our grid network. This is an automated process. Now, once the SonicWall has been updated and then we go to reproduce this test, well, we get a little bit of different results. Here we are running the test again after our IPS team went to work and identified where we had to add additional scripts. So in this additional signatures for these HTTP evasion scripts, we're running the exact same test website, running the exact same scripts. We're able to see where the SonicWall was able to do much better. In this particular case, running through now over 800 different scripts, we can actually see the SonicWall scored much more effective. In this particular case, a short while later, we're at 50% and still no serious problems identified. Once we get to a short while later, we can actually see where the SonicWall is going to wrap up its test starting at 99.4, 99.5, and continuing, counting down to 100. You can see each of these scripts going off, and we're going to get the results of how the SonicWall actually does. Once the test completes, we can see that the SonicWall was able to block all evasion techniques. None of them were able to successfully circumvent the firewall, and SonicWall prevented any breach. Furthermore, in this particular testing, no additional best practices other than enabling security services were required for the SonicWall to achieve this result. All the signatures were caught with default configurations once the intrusion prevention system was enabled. For more information on how SonicWall can protect your network, check us out online at sonicwall.com.